So before I can talk to you guys about prime factorization, I need to talk to you guys about what are prime versus composite numbers. I have a list of prime numbers on the left, and I have a list of composite numbers on the right. Although it is true, most prime numbers are odd, it does not mean that you are prime just because you are odd. So we'll talk about that on that side. 2 deserves a little crown up here. That's my attempt at a crown. 2 is the only even prime number. So what makes a number prime? Let's look at the number 17. So 17. So let's go through our divisibility rules we talked about yesterday. It cannot be divided by 2 because it's not even. It cannot be divided by 3 because 7 plus 1 is 8. That's not divisible by 3. It cannot be divided by 4 because it can't be split in half evenly twice. It cannot be divided by 5 because it doesn't end in a 5 or a 0. 6 is out because it wasn't divisible by 2 or 3. Really, we'll come back to 7s later. 9, it's not divisible by 9 because it doesn't have a sum that's divisible by 9. And then it's not divisible by 10 because it doesn't end in 0. I skipped over 8. It's not divisible by 8. It's not because it wasn't divisible by 2 or 4. So the only factors this number has is 1 and 17. And that is what makes it prime, is that it only has factors of 1 and 17. Which just brings us to the fact that 1 is neither prime nor composite. 1 is neither. It's kind of a neutral anomaly all to itself. So over here, what we're looking at is these are composite numbers, because if we start with like the number 27, yes, it's odd. It can be gotten by doing 1 times 27, but it can also be done by 3 times 9. It can also be gotten. And we know it's divisible by 3 because 2 plus 7 is 9. So we know it's divisible by 3, which also indicates that it's divisible by 9 because 9 is divisible by 9. 33 is almost composite, but it has factors of 1 and 33. And then it has 3 and 11. So some numbers can be considered relatively prime numbers, relatively prime, but it is not. I said it's almost composite. It is definitely composite, but this is why it could seem to be relatively prime. So let's think about a number. 28 goes in the composite side, because it has multiples of more than 1 in itself. What about 57? So let's go through and test it. It's not divisible by 2. Is it divisible by 3? 7 plus 5 is 12. Can I divide 12 by 3? Yes, I can. So I can divide this by 3. 3 goes into 5 one time, which gives me 27, and 3 goes into 27 9 times. So that means that 57 is indeed composite. Again, it is a relatively prime number because it is almost prime, because it only has factors of 1 and 57, and then 3 and 19. Is 19 prime? 19 is prime. 19 is a prime number. 11 is another example of a prime number. So that's just reviewing prime and composite before I go over 1 or 2 examples of the prime factorization to help you guys find greatest common factor. Some of you guys might be thinking, how does knowing prime versus composite numbers help me in math, and in particular with fractions, since my students are in the fractions unit? So here I have the numbers 12
and 30 as my denominators, what I can do is I can factor this to be 3 times 4, and then 2 times 2. And I know to stop there because I have all of these ending numbers are prime. So this can be written as 3 times 2 to the second. If you were actually asked to write the prime factorization, it would most likely want it expressed this way with exponents. So here, I know I can do 5 times 6, and then I know I can do 2 times 3. 5 is a prime number, so I'm not going to do anything with it. So the prime factorization here can be written as 5 times 2 times 3. So again, maybe it's not very convincing yet. Why in the world would I want to use this? Why do I want to know it? What you can see is it has a 2 common and a 3 common. When I multiply 2 times 3, I get 6. I get 6. So this tells us that these two have a greatest common factor of 6 without listing out all of the factors for the number. So that means I can say if I had 3/12, I can divide it by 6 and simplify. I know I can divide both of them by 6 whenever I do this. So if we throw 105 into the mix, I know it can be divided by 5. Let's try to switch the marker. I might find a better one for the next video. 105 divided by 5 is 2 there, is 21. And then 21 can be gotten by doing 3 times 7. So if I was trying to look for the greatest common factor between 105 and 30, well, they have a 5 and a 3 in common. 5 times 3 is 15. So we know that their GCF is 15. It just makes it a little bit faster than listing out actually all the factors for you to have to use to simplify it. So I hope that kind of helps with that. And I hope you have a great day. Sorry about my voice. I'm having an allergy attack, I think.